name is Scott Smith. I'm the IT Director for the City of Bristol. This is session 18 on smart cities. Just a little bit about Bristol. We built a municipal fiber network about 5 years ago that connects up all our schools in our city locations, about 27 locations. And we're just now starting to look into how can we build that broadband technologies, smart city technologies onto that with Wi-Fi and so on and so forth. So we have a couple of presenters here. Okay. So our first speaker is going to be Ken. Or sure. Okay. Sorry. Ken Young's a graduate of Salem State University with a BS in Criminal Justice. Since then, Ken immersed himself in the technology world and made his career over 17 years. Ken's knowledge and experiences ranges from developing and launching an enhanced 911 product, which won several large national contracts, to providing leading-edge technology telephony solutions. Ken now focuses on the prolonged benefits of enhanced communications for enterprise, state, and educational institutions. So, anyway, thank you.
Ready to read that, it's tiny. I wouldn't be able to read that. So it's Friday afternoon, how's everybody doing? You holding it okay? Drinks in 1 hour, so we'll get through this quick. Real quick, it wouldn't pay my parking ticket if I didn't at least talk a little bit about my company. So I just have one little sales slide here. Advanced 6000 is a full-service IT solutions company. We are based out of Buffalo. We have a couple of data centers. We do everything from co-location, telephony, which obviously the voice over IP piece, and the smart municipalities that we're going to talk about today. Just a few of the things that we do. And in about 9 different cities, covering pretty much the Northeast. That's it for Advanced 2000. I'm very happy to turn it over to Mr. Neil Tilley, who we have the great privilege to have here with us. I thought I was going to be having to do the entire thing, but now Neil got to come with us, and he's got a great history and background with education, especially right now, but all the way back to healthcare. So I'm going to let Neil take over on the smart cities.
Hello. Yeah, so I hijacked the presentation. That's what he's basically saying. Yeah, so I was lucky enough to be visiting, so the team asked me if I could spend some time with you. So what I wanted to do is to... I'm taking it out. I have taken it out. So obviously I'm from Connecticut, you can tell by my accent. So I've spent a lot of time doing smart cities around the world, and I can tell you right now that my focus for the last 3 years has been education. And but I've traveled, worked in Europe, worked in North America, working in smart city councils with Alcatel-Lucent, working with the service providers. And I have to kind of jump at this because this is something that I get to do. I talk about education all the time, so now I get to talk a little bit about smart cities. And some people say, well, what is a smart city? Because there's a definition issue, which is that we all have a different view. It's a bit like 6 blind people and an elephant. They don't know what it is, but if they all got together and chatted, they go, oh my God, it's an elephant. Maybe the smell would have given it away, I don't know. So I asked the question, what is a smart city? Did you know in Europe, a smart city is the infrastructure, is the smart infrastructure that runs the city. So as you can see here, it's urban rail, it's road, highways, it's the oil, gas, electric, it's the seaport, it's the freight system. Would you say that's the same in North America? No, not at all. In fact, the main constituents of a smart city is actually all of those public services. Public safety, higher education, K through 12, healthcare, obviously from both emergency services and triage, and of course all the other facilities inside of state and local. So there's actually a bit of an international sort of situation here where we go, oh, well, hang on. The rest of the world thinks smart cities are the infrastructure, and North America looks at it as one's the public services. But actually, they're both right. They're both right in the sense that actually the infrastructure that we are looking at inside of the infrastructure and transportational systems of our highways and our cities actually are the starting point for a smart city infrastructure. And so I've got some examples here. I'm not going to have time to talk through them, but you can see here from the fiber rings that we're putting out inside the typical utility systems to the substations. If I go to the railway systems, we're using the rail systems to run conduit all over the country and create extremely fast fiber backbones. And tying these to sensory industrial sensors. So we know exactly where the trains are, we know how many people are on the platform using video analytics, we're using all these different technologies inside the smart city. But which we obviously can look at the roadside now. You can see here, Alcatel-Lucent has worked on many highways across North America and across Europe. We have this, we actually build these, you'd be amazed. I get very excited about these things, which is very sad, but I get excited about the signage on our roadsides around the world because there's so much technology just in that signpost. What just seems to tell you to buckle up actually has more technology than most elementary schools have. It's incredible. So you look at the fiber technologies that we're using here, and what's important, and this is the reason we can get to my point, is that the issues and the reasons why the infrastructure smart city architecture is very important to the way that we look at smart cities over here in terms of public services. Because the same reasons and tools and technologies are the things you should be looking at. So for example, the reason why it's getting like this is 270 billion applications that are out there in 1.5 billion smartphones. And then the use of these enterprise, these mobile apps as enterprise toolkits is increasing exponentially by 4 based on this. Now what do I mean by that is it's really the Internet of Things that we're talking about. So this is what smart cities really means and what we should be kind of looking at. How do we leverage this idea of the Internet of Things? How many people here in their organizations have an Internet of Things strategy? Okay, just me. Education has had Internet of Things for a lot longer than most people would realize. In fact, Internet of Things has been around for a long time. It's kind of resurfaced recently. It was a British guy who named it Internet of Things as well. That was just a British. It's got nothing to do with my presentation. So the thing about smart cities is that we need to leverage the mobility of the devices and also the power of Internet of Things. A wise man said to me once, an Internet of Things is split. The Internet of Things is actually split into 2 types of things: smart things and connected things. And there's a difference. So think about everything in your municipality. Okay, think about all the devices that are just connected. They don't do anything; they're just connected. And now think about all the devices that are smart, that are producing information, that are able to analyze information and make decisions. Now that's the next level up. Those are devices that are able to pump out information, alerts, notifications. And that's why the Internet thing is such an important, crucial part of any municipality's strategy. The other thing that Internet of Things brings is a scary reality that our threats that we're looking at in terms of our classical building infrastructures and our standard private wide area networks and to some extent our metropolitan area networks that we've built over time, is the threat levels are changing. The scariest thing about these stats is the second highest per capita data breach cost is higher education. It's not commercial, it's not bank, it's higher education. No, it's 105%, it's 103% more than the national average. And the reason why is because the Internet of Things, this sensory network that we're talking about, that we're trying to build out, actually brings this, what we call the Wave 3 threat, which is essentially devices that are smart, that are basically able to be hacked, are touching our infrastructure. They're touching our utilities. They're touching the flow of traffic. They're touching in a hospital. They're touching the medical equipment that's telling us how well a patient's doing. And it's just the same inside of education and in public sector and across state and local. I haven't got time to talk about all these things that I wanted to talk about. So if we actually look at what the true infrastructure that we should be considering Internet of Things, considering what we've learned from these massive fiber-based metropolitan area networks that we've created in the smart city arena, both in infrastructure and in municipalities. So here's a classic municipality. We've got a stadium, we've got libraries, we've got some administrative offices and corporate and local business, state and local buildings, and then we've got an engineering faculty. If I jump forward, what we have to be able to do with this new world of leveraging all these sensors and these devices and this mobility is that we need to be able to profile across a single infrastructure. So how do we do that? We use standards. Okay, so what we're using is software-defined networking. So my first point that I wanted to bring up is, as an advice to the smart city, when you're looking at your strategy, you're looking at what you're doing in terms of your education, and most importantly, the thing that we're all really here about is shared resources. Leveraging the funding and the budgets that we have and sharing resources. We need to consider software-defined networking, and we need to consider the ability to profile across the network. So what we did was we built this smart city using this technology, and then what we're able to do is create what's called containment layers. And this is the most important phrase that you will take from my session, is containment layers. And this is the next generation in architecture that we're using in times, which is really crucial to smart cities for the future, is the ability to have a physical infrastructure across a huge area and create this ability to create containment. Because it's the only way we're going to really be able to leverage these technologies, these single fiber infrastructures for that many devices with that much power and that much smartness, if you like. Smartness, I think that's a good way of saying it. So here, for example, across all these buildings, across this single city, all of the HVAC systems are now contained in a virtual layer across the entire network. And that means that from a central point, I can manage both from a safety, both from a cost, and both from an operational perspective. So now we've got a shared resource in a stadium, in a building, and in a university building. And now think as districts, as state and local councils, or even just as a geography, the cost savings, but also the benefits that would bring. The next thing, so obviously here we have campus security. So from a public safety perspective, we're now sharing all of the cameras, all of the video analytics that we're able to do now to provide and create a very publicly safe environment using this smart city environment. And then, of course, the other thing is that we can start to get really focused on areas, containment areas that focus with specific requirements. And this could be anything from instrumentation inside of for example, in a utility like a gas or a power plant, obviously things like thermostats and controls are controlling all of the pieces, the operational pieces. And now you can now use this smart environment to do that. So in the case there, instrumentation. And of course, the other thing that this architecture brings you is the fact that you have much more visibility, much more statistical reference. So so from a central point, we can break some of these costs, the costs of resource of running an environment. Ooh, we've moved on. So what has that got to do with communications? Because of course, with Advanced 2000, what we want to talk about is a little bit about voice and communication. So actually, from a smart city perspective, just like inside, if anybody's from a school district, you might have heard that E-rate modernized a couple of years ago and is pushing technology to broadband into the classrooms, mobility, wireless. It's the same in a smart city. With this step change to the way that we run the architecture so we can get the benefit of these things. we also can kind of look at the way that the communication system, because it's a unified, converged environment. And something that smart cities haven't really taken advantage of yet is communications. In fact, as I say here, have we mastered communications? And this is my example of a fragmented communications. This is still going on. People are ringing multiple phone numbers for individuals. They're sending emails, social media. They're creating voicemail on colleagues and other people's devices. And it's just not a good use of time. And so in this world of multiple devices and multiple technologies, you know, what we've done, and with Advanced 2000's help, is create a communication model that you should kind of look at from a smart city perspective, from a municipality, and from the individual components of a smart city, from the healthcare to the education to the public safety. And you can see here, I'm not going to have time to go through it, but communication support practice, how are you supporting the smart cities, communications architecture, the communications infrastructure itself, how are you making sure you're leveraging all the different things from E911 to the PSAPs to the last presenter. We've been doing a lot of our own emergency notification systems inside of the building, not for the first responders, but for the people it affects. Because that's a piece that people miss, which is when you lock down a school because there's a threat of an active shooter, it's everybody else who's in that proximity who needs help with notification. But that's not the first responder or the public safety's responsibility straight away. It's obviously the threat. So we are building these things into the communications architecture of the actual city or the municipality. Reachability. Obviously, as a public service, public administration, our job is to provide a civil service. So reachability of those services is huge. It's hugely important, and we're leveraging core technologies such as proximity, such as collaboration, and IM and presence. And of course, that's something that you need to layer on. And the final layer, which is over here, is the connected experience. And this is the whole picture of a smart city. Good example, in Germany, they have started to put the pedestrian crossings are now in the pavement. Did you know that? Isn't that crazy? Because so many people are staring at their phones that they're getting knocked over and killed. And they're falling off cliffs. it's just the way we are. So they've actually built, so they've had to put their, I suppose its highway system is now in the pavements. Sidewalks, sorry, my apologies, that was a British thing. The sidewalks to protect the citizens, because they've seen the number of devices. It's actually changing the way that our citizens are living their lives in our cities. I'm sure that we'll see some cities, maybe the city of Bristol might be the first in America, hey? We could try and help you with that. See, I'm always working. So of course, the other thing about the communication architecture is the technologies behind it. And of course, session initiation protocol, which is something that some of you might know. Actually, Alcatel-Lucent was one of the founders of that protocol. So you know, we designed that many years ago in Europe, and of course, it's just gone crazy and taken off. But it's lightweight, it's self-policing, self-healing, and that's something that's really important to a strategy around a smart city. A technology that's helping communications. The other thing is I have a slide on that. No, I haven't. Is WebRTC. This is another thing that you should go from this session and go and look at, is WebRTC. Real-time communications using web is like the Russian doll of SIP. It's like SIP is really lightweight, it was better than H323 and all these other proprietary protocols. And now we've got WebRTC, which is a RESTful API. So it means we can insert it into the application interfaces of web applications in the cloud. Now the thing about WebRTC, which is really powerful, which smart cities haven't leveraged yet, is the fact that it's so lightweight and easy to put in to any of these applications, mobile clients, any verticalized instrumentation. But we can put video, high-def video, we can put multi-party, multi-conference, we can put in lots of technologies like customer service, skills routing, emergency services. And this is something that I wanted to show you here. These are all based on a WebRTC model. And we call it the Safe Campus. But essentially that could be the Safe City. And this is kind of controversial because it kind of it's kind of an accelerated view of E911, the next generation 911, the next generation PSAP. Because what we're doing here is we're using technology they haven't even looked at yet. And that WebRTC environment, just to give you some example, V9K, I think that's the acronym. Google have just signed off and should be releasing it soon. It's a virtual MCU for WebRTC, which means high-def video conferencing for multiple parties in web. So that's huge. That reduces the cost of being able to do video. Now, where's the one place we need video? In response to 911. If I'm on a campus of a university, Gordon College, this is a good college that we work with, if you press 911, the nearest camera is already immediately posted to the security hub. So they can see the proximity of where you're calling 911 from. So they can get a good kind of an awareness of what's going on. And that's exactly the sort of thing that the campus could be able to do and the public safety environment can do. And that could be anywhere in the city. Also, broadcasts, so AVBS, the fact that I could broadcast in a street near a digital signage or near a street light and talk to people and say, hey, police are on the way, we can see you, we know what's going on. That's the sort of environment we're talking about. So these are just some of the examples of using WebRTC. The final part I wanted to do, how am I doing on my time? 3 minutes to go through the main part of the presentation. I'm joking. The other thing that municipalities talk to me about is essentially what is the best communication architecture? Is it build their own? That wasn't 3 minutes. Oh, it's 3:19.
Your phone is fast. British.
I just can't finish the slides. All right, no, I'm joking. You can see here a lot of information. So basically, I'll run to the summary because I've run out of time. One of the things that people ask me about, because we obviously build communications architectures for municipalities, school districts, universities, hospitals, public safety, is what is the best architecture? Is it a premise-based system that we completely lock down? Is it a cloud-based hosted solution that we get somebody else to deliver and we just pay per use? Or is it a mixture? And of course, you could probably read these and get the same result, which is it's really a hybrid. It's really what you're trying to do. One of my first jobs that I had was designing command and control centers for Motorola for police. And the first thing I did was everything was completely point-to-point, no point of failure, constantly working, everything, blah, blah, blah. And I was the first engineer to come in and say, why don't we put this over IP? And I, of course, was met by a wall of negativity. And many years later, of course, a lot of those command and control centers have all moved to IP, and we've created some very clever technologies. Same with communications, and it's one area that I feel very strongly about, is building a hybrid model. One of the things that we've just recently done is we've just created an occupancy solution for hotels. Okay, so just bear with me because I know that's not you don't have many publicly run hotels. But the occupancy model is basically a hosted environment for communications. Where I'll have to shout. That's probably better actually than that anyway. So the final thing I was going to say was the occupancy model in hotels is actually very powerful, because what happens is the hotel gets a full system, but only gets charged for usage. So say that hotel only goes along at 70% usage for a week, they only get charged for 70% of the technology they have. So there is actually a model for smart cities, communication and infrastructure, where essentially you build out this bigger model, and then if you only use 70%, you only pay. Now that means seasonal. It might mean that a city has an event where suddenly all the resources are stretched. Maybe there's a weather-related scenario. So during the winter, hardly anybody comes, and in the summer, everybody's visiting. So there's things like that that we haven't explored in smart cities. And the vendors like Alcatel-Lucent, like our previous presenter, Bayer, and
Francisco, people have the ability to do this. But it's the municipalities and the smart cities that need to ask us to do it, you know, because we'll continue to sell you premise-based equipment and support models until you ask for it. But their technology's there. In fact, Advanced 2000 is one of our most advanced partners who's putting these type of pay-for-usage solutions together. So please come and talk to them. That's been basically it. Obviously, I've run over a little bit. I apologize. Happy Frosties.
Good luck. That's fine. You have to talk about.
Yes, you got that one. Can I not be blamed for the microphone thing? That would have happened anyway. Just...
Thank you, Neil. Next we have Stephen Casaletta. He's from FIS. Stephen's been in fiber optics since 2008 when he interned in marketing and fiber instrument sales. He moved to sales and advanced to regional supervisor and now a territory manager where he's responsible for sales and projects across half of the country. Stephen's recent accomplishments include successfully executing a PTC initiative for Amtrak, supporting the massive DAS installation for 270 plus substations throughout New York City, bringing cell service to rural areas, and presented Smart City Technology at the first annual Building Technology Integration Conference in Detroit, Michigan. Stephen, you're up.
I'm going to try to make sure I get back down a little back there. So if you can't hear me, just wave at me. Try to project a little louder. There we go. All right, so tell two smart cities again. Awesome prelude to this. I think both of our presentations go along very smoothly. So I'm going to try to talk a little bit about what's happening right now as far as smart city technology, what it means to us, what can you walk outside and touch and see how it's affecting us in our day-to-day life, whether it be, you know, everyone always wants to talk about more bandwidth and higher speed internet, and I want to get on Call of Duty, my Netflix faster, but it's not all about that. It's about efficiency, it's about security, it's about growth. So let me make sure I have. Oh, I'm having technical difficulties with this too. Okay, there we go. All right, so again, yeah, what's happening here is not happening up here. Apparently everything's shutting down up there right now.
That's it.
Yeah.
Again, I didn't do anything.
You're banned. Never come in here again.
All right, so we're going through the introductions there. Sure, okay. So again, fiber instrument sales, just have to give ourselves a little plug here. We've been around for 30 years, and actually this is our 30th year, and Frank Giotto, our owner, takes a lot of pride in domestic manufacturing and domestic projects. So we're not only fiber instrument sales anymore, we are Giotto Enterprises. We're involved in plastic injection molding, precision machining, LEDs, our cable extrusion for fiber optics, military and broadcast assemblies and technology. And the reason why I bring that up is because it allows me to really touch a broad range of infrastructure projects throughout the country, throughout the world, whether it be, what I'll talk about in a little bit, whether it be PTC, like Scott mentioned here, which is safety on the railways, or a transit wireless project where now people can get Wi-Fi signals right in the subways where historically you couldn't have that. So along with distribution manufacturing, we offer a whole lot of services. Particularly, we do a lot of trainings. I was actually just down here maybe 2 weeks ago at the 55 Farmington address doing a couple fiber optic workshops. I also want to invite everyone to our Northeastern Fiber Optic Conference, the NFOC. It's actually sponsored by Fiber Instrument Sales. And I think last year we had 100 distributors, we had about 300 attendees, and it's right in central New York, so I want to invite everyone to that, to reciprocate inviting me to this. So thank you very much. Okay, here. So what is a tale of two smart cities? Obviously, it's a play on Charles Dickens, great book. But according to the Business Dictionary, you can see what it entails by definition. developed urban area that creates sustainable economic development and a higher quality of life by excelling in multiple key areas: economy, environment, people, living, and government. But really, what does that mean day to day? What does that mean for us? Oh, can you see everything back there?
Yes.
Okay, I just want to make sure I wasn't blocking. Okay. But what does it mean for us? Again, I said before, it means efficiency, it means safety, and it means communication. So smart grid technology has to do with how things interact and what we do with that information. So wind turbines is a big one. That's kind of a big push. Green energy, renewable energy. I'm going to talk a little bit about net zero communities. Has anyone heard about net zero communities before? That is the future. Sustainable power for a community. So wind turbines, you think, yeah, okay, green technology, but how does that really fit into a smart city infrastructure? They communicate with us. They communicate back to a head end. They take the variables from the environment that they're in, they go back to a head end, someone's controlling it, they alter what it's doing to really maximize the efficiency of it. And how that works is, just as an example, so you have your lines running to these wind turbines. You have your lines running to these wind turbines and they interact with the environment. The optimal wind speed of a wind turbine, does anyone know what it is? 27 to 29 miles per hour, okay? So when the wind is going 27 to 29, you are getting the most power, the most output out of these wind turbines. Well, what happens when it's below 27 to 29? What happens when it's higher? How do we adjust these blades for that? We actually get that input from the field, again, going back through a fiber, the wireless, whatever the infrastructure is. They go back to the head end, they will actually adjust the pitch blade on those on wind turbines to make sure that it's handled properly. So when the wind, when it's not in that optimal 27, 29 miles an hour, the pitch will bend up a little bit, so it's not as much resistance to turn the blade, and you're still getting some output of energy through there. On the flip side, when that wind gets up to 50 miles an hour, you will blow out your wind tower essentially. The blades will over-rotate, you'll blow out the generator, and however many hundreds of thousands of dollars that's going to take to replace, get guys out there, repair. So they actually rotate the blades to optimize lower wind speed, put it at this your original setting at optimal wind speeds, and then shuts it down when they start getting up to 50 miles an hour so you're not having blowouts out in the field. Wind turbines is a huge technology, especially in the Northeast is coming, and out on the tip of Long Island, you're going to start seeing some wind farms pop up because they have that constant wind speed that they're looking for. Solar farms as well. Solar farms are everywhere from my buddy's roof that he just bought a house on that got the great rebates on, to entire fields that support those net zero communities I was telling you about, which I'm going to talk about in a little bit there. Similar concept. Does a solar farm, does it have to change at all throughout the course of the day? What affects a solar panel? The sun, okay? So when's the sun at the highest peak? You know, daytime to around noon. You're getting a different output, or you're getting a different input of energy, which is affecting the output as you would at, say, 8 o'clock, 9 o'clock, midnight, when there is no sun. Going back to the smart city infrastructure, just smart technology in general, they can actually control at when the solar panels are operating at their peak operating position. And the reason why they do that is because actually in the Northwest, solar farms are becoming a problem for communities. There's so much energy being produced by these solar farms during peak hours that the natural gas generators are shutting off. They're shutting off during the day because they have this huge amount of energy coming into it. As soon as the sun goes down, which is what happens when the sun goes down, everyone's getting out of school and work and they're going home and they're back on Netflix, I was saying earlier, they're back on Amazon, Hulu, whatever it may be, rolling blackouts. Okay, we cannot have that. It's awesome to have the green renewable energy during the day, but how do we transition from using that energy to using a backup source when that sun is not available? So what do? Has anyone ever heard of Pacificor? They are a massive power company in the north, actually the whole west coast in general. So they kind of took it amongst themselves to form a coalition power plants essentially across, what was it? I know it's over there, I apologize. It was Wyoming, Idaho, Oregon, I want to say it was Washington, don't hold me to those. But basically they developed this really intricate network of communication between these states. So now they're transferring power intra-state, or between states. So now what's going to happen is, or what is happening is, now you have Northern California, they're firing these solar farms all day long. Nothing's changing. They're taking maximum advantage of all the sun energy that's coming down. Well, as their next door neighbor, Oregon, maybe when California's firing on all cylinders, Oregon's not. They're relying on those natural gas power plants. Why would they do that? The natural gas power plants, if they shut off a generator, which would happen when they start having all that power from the sun during peak hours, can take up to 4 to 6 hours to turn back on safely. There's that rolling blackout period right there. That time from when the sun goes down to when people are using it, and the time difference it takes the generators to turn back on, 4 to 6 hours. You can't have that. You'll have one state that's running off the natural gas, you'll have one state that's running off the solar, they'll transfer power as needed through these intricate communication networks, and you made the best of both worlds. You have the consistency of natural gas, you have the cleanness, the naturalness of the sun during the day. Does that make sense? And we got smart city. We are communicating, we are sharing our resources. I believe I heard that there. We are sharing our resources through communication through the most efficient ways possible. All right, electrical grid, not terribly, not as exciting to me personally as the wind turbines and the solar farms, but here's an interesting stat. Again, it has to go with real-time evaluations, and monitoring, and testing. Did you know roughly only 10% of all critical load-bearing transformers in the country have real-time gas monitoring systems? Doesn't that sound like a really low number? I mean, think about it. So when I say critical load-bearing, what comes to mind? If you had to guess, what would you say? Come on, I know it's the last one. Exactly. Emergency services. What's another good one? Hospitals. Okay, educational facilities, financial facilities. What would happen if, God forbid, something happened and the New York Stock Exchange broke down? All hell would break loose. It'd be like Batman. You know, you saw that with Bane, it was terrible. But in all seriousness though, smart city, the infrastructures that are being put into place have to be able to accommodate the real-time monitoring of these transistors up there, and you just see it. We can't go out there living our lives in 2016 only monitoring 10% of critical load-bearing power sources. The last part, I like to touch on it because it's personally interesting to me. You know, even the power supplies are changing. It's not all about fiber optics and wireless and all that. I mean, even if you break it down, like, how are we storing this energy? It's just, we're getting smarter at what we do. Lithium-ion batteries, they're not going to support what we do. They wear out, they're big, they're bulky, you got to replace them. You know, supercapacitors, they discharge fast, they recharge fast, they're super expensive, but that's where everything is going. That's a little side note I like to throw in there. So I'm talking about all this efficient energy. Again, it's communication, it's monitoring, it's adjusting, and then last but not least, it's how you store it. But I could talk another 2 hours about that if you let me. So, safety, mass transit management. We talk about more, again, efficient energy, clean energy. We talk about public transportation, bicycles, walking. I was actually at ESF in Syracuse, and there was a professor from Harvard that was talking about the comfortability of walking paths in urban environments. It has to come with everything from how the sun hits you and the architecture around your walk, the foliage, Wi-Fi, of course. So mass transit and public transportation is not going away. It's only going to get bigger, especially with all the millennials coming up. So how does smart city affect transportation? Well, alerts. All right, how many here use their phone for GPS when they travel? I know I do. I got actually really nervous last night when I was driving down here. It's like, all right, it's only 3 hours and 20 minutes. And all of a sudden it bumped up to 4 hours. What the hell happened? There was an accident. It knew literally 2.5 hours before I got there that I was going to be slowed up for 40 minutes. How is it doing that? Communication. Going back to the emergency services, the ambulance, the policemen, where are they reporting this to? What is going on with this information? How is it getting out to the people? Cellular, Wi-Fi, smart city, traffic alerts. So again, accidents, weather alerts we get. I've been getting those amber alerts lately out on the road. Don't you say that's important? Was that around 5 years ago? 10 years ago? Were we getting those alerts on our cell phones at that time? No. The evolution of things. It's how we communicate. Flow of traffic. When you think about it, like, all right, well, Steve, what are you talking about? Mass movement of a lot of people out of a particular area can be a nightmare. When this place gets jammed up, you know, probably this convention, I saw there's a bunch of dancers out there. My little sister was a dancer, so I know how those recitals go. If this place is packed, how long does it take to get out of this parking lot? It takes time. All right, so they can monitor the flow of traffic leaving an event. A little factoid I like to say about that is Coors Field out in Denver. Anyone a baseball fan? Coors Field, they actually have anywhere between 8 and 10 engineers on site for every home game, monitoring traffic in the city to get people out of that stadium the most efficient way possible. They get in there and they communicate with the traffic systems. They will actually change the patterns of the traffic lights to get people out safe. They say 35 to 40 minutes. I'll believe it when I go to a Rockies game, but it's not just applicable to sports events or education events. God forbid, and actually one of the first trainings I went to here, we were talking about Superstorm Sandy. Talking about a mass exodus of people getting out of the danger zone. We need to be able to control how we can get people from A to B the fastest, most efficient way as possible. Okay? One little note I had in my bio, I guess you could call it, was positive train control. This one is actually really interesting. It's happening a hell of a lot faster than anyone thought, in my opinion. So does anyone know what PTC is? Positive train control. You know, we've all heard the unfortunate tragedies. You know, trains derail. I know there was a couple Amtrak ones over the years, probably not too far from here. You know, a car will get stuck on the railways. We move so much goods and people on trains that we have to monitor. We have to monitor on these railways that have been put in from, geez, I was actually on a railway, there's still soot on the ground, and they joke, oh, that's when they dump all the coal out. These railways are 100 years old. How are we monitoring along these railways? So positive train control is designed to do a few different things. Allow for appropriate train separation. One train's not right on the caboose of another train. You don't want that. This will monitor how far apart they are. I'm going to show you a little bit in a second of how it actually does it. Line speed enforcement. You know, these trains, they have certain load values to them. You can't have, you know, whatever number, a super heavy train coming in hot around the corner, tip over. All right, you have a bunch of passengers on there. You can't maneuver corners if you don't have the appropriate weight restrictions. Again, temporary speed restrictions. That also kind of plays in a little bit too. Sometimes switches get flipped inadvertently. You don't want a train that's supposed to be going this way, you know, to keep going on its path. Say it's not stopping in Bristol. It's going right through to New York, going straight. Well, flip a switch. Now it's coming in hot right to the station. You see how that could be a problem? PTC will stop that. And then rail worker safety. You forget, these guys that are working these railways, it's dangerous. They are literally right on top of the railway setting up these projects. Again, all the cable and duct that's being pulled through, they are right on top of it. So the trains, they can actually communicate to each other and with the head end where there is a work zone. They can change the way they're traveling, slow down, maybe the controller can take a different route, get them out of heavy traffic zones where there's workers on the tracks. Now, bear with me here. You're about to see some real life stuff. All right, so that handsome guy right there, that was actually me on the railway in North Jersey implementing a PTC project. And this is happening right now, actually. Amtrak declared that by 2020, 100% of all Amtrak railways are required to have PTC, positive train control, along their railways. All right, and I know it doesn't seem like much, it kind of just looks like a big aluminum box there. But what's going through here? What's going through that? So one, it's tapped into a fiber line. Again, your dusty cables are flowing along railways. It's going through a fiber line that goes to the controller, the station. It goes to goes to the city. Everyone's monitoring, making sure everything's going smooth. There's actually a radio head that is connected inside of this hut in here. Okay, that when the train goes by, it communicates in real time with every single car that goes along that railway. It knows what's in it, how many there are, where they've been, where they're going. It knows all of that, real time. And I like to show this because this isn't 20 years down the road. This isn't the future. This is now. This is happening as I talk right now. There is someone with a pickaxe in the ground putting in one of these huts in there. And plus, I like to, I don't just sit behind the desk all day. I do get out there and get dirty. To give me a sledgehammer, take a picture of me. I'm like, I wouldn't know that I'm actually out here doing this. So again, real life stuff is happening right now. Okay. Then fiber optics. This is kind of this one's always going to be near and dear to my heart. That's where I came up. We all know what fiber optics is by now. Verizon talks about it. Their fibers. Google is all over the country right now setting up fiber to the home networks. I'm sure one of us has said here, man, I wish I had a fiber right to my desk at the office. Fiber to the home is such an intricate part of smart city infrastructure because the word I keep saying is communicate. How is everything interacting? Is everything interacting at the appropriate speeds? There was a report I was looking at. The average house downloads 17 gigabit of material per month. 17 gig. Can our traditional DSL lines handle that? Maybe for a little bit more. There's again the Hulu's, the Amazons that live stream. We need fiber optics to get to these houses, and it's not even to the house. I mean, that's what you hear, fiber to the home, but it's so much more than just that. It's FTTC, fiber to the curb. Okay, you tap off some dark fiber, and I saw that nice display out there that showed the fiber networks all throughout Connecticut, New York. Take a fiber off there. There's fiber running all over the place, even up where I am in central New York. Not even New York City, way the hell up north. We have a 240-mile fiber ring going around the Adirondacks. People are tapping off the left, well, trying to tap off on the left and right. Bring a fiber to the curb, put your switch right there, bring out a line. It doesn't even have to be fiber at that point. Bring a DSL line to each house. You're getting that big hose as close to your end user as physically possible. Okay? Fiber to the node. Similar concept. Every couple houses, maybe you got a node through there, you can store a switch, bring a fiber in, bring them out to each house. And then again, obviously you have fiber to the home, which is the end game for everything, is where you actually have fiber feeding right to where you live, and possibilities are endless there. The advancements of fiber, it's mostly a single mode fiber, but even multi-mode fiber, they're pumping 10 gigabit over 650 meters now. So the advancements of the infrastructure of fiber to the home, how it's being, the architecture of it, how it's being designed, it's changing, it's happening, and it's going to be here. Fiber to the MDU, multiple dwelling unit, this is a great example. So say you bring fiber to the building. The PLC splitters now, you can actually splice one of your incoming fiber, split it out 32 ways, each floor gets a fiber. Again, the technology of the glass is getting better. Now you can split your energy so much more efficiently. You can put multiple wavelengths out over an individual fiber. Because now it's not how many fibers do you have, what is it? It's what can you put in that one fiber that you have. Mux and demux, cramming wavelengths, take them back out of the end user. I was at a training, I think it was OFS. They're coming out with multi-mode fibers now where you put 4 wavelengths on it. When I first got into fiber optics, they couldn't do 10 gig more than 100 years. So it's just a progression of things. Okay, the fiber and wireless relationship I want to talk about just a little bit here. I don't know how much time I have left. Probably not much. I had to stop much. I didn't press that. All right, fiber and wireless relationship. There was a good question earlier. I think we were talking about cloud computing. And fiber and wireless relationship. everyone always wants to ask, what's the next progression? What's next? Fiber is great. Wireless, that's the next big medium. They're not two separate things. They are, but they go hand in hand, okay? Wireless networks need fiber backbones. That's all there is to it. The reason why I bring that up is because now we're talking fiber to the home, we're talking fiber to the MDU, fiber to the curb. Okay, well, how do you get this technology, this bandwidth to the person walking down the street? Going back to that transit wireless, the Omnibus project. They ran an 864 count fiber optic cable through 270 substations in New York City. Why? Every person in that subway now has Wi-Fi and has cell service because of that 864 fibers now has a radio head at every single substation. You want to know what the reasoning behind that was? The really big push? It's not so people can get on Facebook and Angry Birds. Security. One of the main things behind that was to prevent domestic terrorism on subways. This is literally could be life and death, being able to communicate. And then that goes into the kiosks. That's going to be a huge thing coming up. Just the intelligent kiosks at every hub. They need to be fed by something. You go in, you can see your railways and where you're going, the subway stations. And then one other thing too. You're walking down the street. You want to get on your phone. Not everyone has a data plan. So when's the last time anyone actually used a payphone? Okay. What they're doing in New York City right now, I don't know if anyone's heard about this, is Link NYC. They're taking all these decommissioned payphone booths, turning them into DAS, distributed antenna systems. Every payphone booth you walk by now is going to be a 150-foot Wi-Fi radius. Pretty cool, right? So now all those alerts, all those traffic patterns, all your apps you use for your Uber cars and everything. Now you can get them anywhere. And as far as money, which I'm going to wrap up right now, $200 million are estimating to install that, okay? $1.2 billion in revenue estimated over the first 10 years in advertising alone. So smart cities can equal some green wallets. So I got to wrap up here. Again, I'd like to touch a little bit local, but CT gig project, and I was going to talk about just the bandwidth requirements of schools. I think you guys got a pretty good grasp on that. And then just a couple of factoids I'd like to end with, and the one I really want to touch base on is Forbes predicts that by 2020, that smart city markets will be worth $1.5 trillion. Trillion. TR. This is something that's happening now, that there's, people up here that are a hell of a lot smarter than me at this stuff. They're doing great things with smart cities. Things are changing. So, sorry for going a little bit long. Hopefully everyone heard me. I'm sorry we didn't have a mic. And any questions before I get out of here? No? Thank you very much,
Thanks,
everyone.
Stephen. Thanks.